Hello everyone. In this video I'm going to explain about friction and normal force. In this drawing, for example, we have a box over a surface and there are four forces acting in this box. Let's investigate forces on objects. Friction exists when two objects rub against each other. Friction is a rebellious force that opposes motion. For example, when a force to the right is applied on the box above, friction between the box and the ground points in the left direction. Friction always points in the opposite direction of motion and applied force. When a force to the left is applied on the box, friction between the box and the ground points in the right direction. Friction, once again, always points in the opposite direction of an object's motion and opposes any force applied on the object. If no force is applied to the box, there is no friction. Friction only exists when an object is pushed or when it slides. So if a box is just there, stationary, and if it's not on an inclined plane or something like that, then there's no friction. Friction is proportional to the normal force. The normal force is the force between a box and the ground. It is a contact force. Normal force exists between two surfaces, pushing against each other. According to Newton's third law of motion, every action has an equal and opposite reaction. When a box is over the ground, the weight of the box pulls it down, but to prevent the box from accelerating downward, the normal force of the ground on the box pushes it up. The net acceleration in the vertical direction becomes zero. So the box is not accelerating vertically, which means that the weight is balanced by the normal force. Friction is proportional to the coefficient of friction. The coefficient of friction depends on which two surfaces are rubbing against each other. Each pair of two surfaces are composed of different materials and will have a unique coefficient of friction. Rubbing my two hands together has a different coefficient of friction than rubbing my hand with a piece of paper or a paper and another paper. Each pair of two surfaces will have a different coefficient of friction. The coefficient of friction can be static or kinetic. Static friction exists between, for example, a box being pushed but that remains at rest. The static friction is then equal and opposite to the force applied. Static friction exists for objects that are stationary but that are undergoing a force. Static friction increases with the applied force, but then it reaches a threshold from which the box begins sliding. In other words, static friction has a maximum critical value from where the box begins to slide. Any force applied greater than the maximum static friction will lead the box to accelerate. Once the box is sliding, a different type of friction acts on the box. It is called kinetic friction. The coefficient of kinetic friction is typically smaller than the coefficient of static friction. That means that it takes less force to keep a box moving at a constant velocity when compared with the force needed for the box to begin to slide. So coefficient of kinetic friction is usually less than coefficient of static friction, which means that the force needed to keep the box moving at a constant rate will be less. Unless you want to accelerate the box, then you apply a greater force than that. Let us work a problem. Suppose that there is a 4-kilogram box over a table. The weight of the box is the force of gravity on it, which is F equals ma, mass times gravity, which is acceleration. The weight then will be 4 kilograms times 9.8 meters per second square, which gives you 39.2 newtons. Since the normal force prevents the box from going through the table, the normal force must also be 39.2. Suppose that the coefficient of static friction is 0.2. The maximum static friction is mu times normal force. Mu here, this little u symbol, mu in Greek alphabet, stands for the coefficient of static friction. So you do 0.2 times 39.2 and you get 7.84 newtons to be the maximum static friction. So if a force of 7.84 newtons is applied to the box horizontally, the box will begin to move. Suppose that the coefficient of kinetic friction is 0.1. Kinetic friction is mu times normal force, coefficient times normal force, 0.1 times 39.2, which gives you 3.92 newtons. Which means that if a force of 3.92 newtons continues to be applied to the box, it will move at a constant velocity with a net force of 0. Newton's second law states that F equals ma, force equals mass times acceleration. So if the net force is 0, the acceleration is 0, but the box is still moving at a constant rate. If a force of 5 newtons is applied to the box, it will then accelerate since that force is greater than friction. The 39.2 from the normal force will cancel the 39.2 from the weight, and the 5 minus 3.92 will give you a net force of 1.08. And the acceleration will be F over m equals a, 1.08 divided by 4, which gives you 0.27 meters per second squared. After 3 seconds, the box will reach a velocity of, assuming initial velocity is 0, because it's just now beginning to move. So Vf equals Vi plus At, so Vf equals 0 for V initial, plus 0.27 times 3, which gives you a final velocity of 0.81 meters per second. After 3 seconds. The displacement in that time, how far will the box move in that time, will be 1/2 the average velocity, which will be 0 plus 0.81, times 3, which gives you 1.215 meters. And so forth. Now, if the applied force is now removed, only friction will act on it, slowing down the box. The net force now is then 3.92 newtons, but negative because it points in the left direction. And acceleration will be force divided by mass, which gives you the acceleration, negative 3.92 divided by 4, which gives you negative 9.81 meters per second squared. And the equation below can be used to find how long will it take the box to slow down to rest, because now only friction is acting on it. Time to slow down to rest with initial velocity of 0.81 meters per second. Solving for t, we get 0.826 seconds, how long it's going to take for the box to slow down. Not a lot. It's going to be less than a second. The box will stop. So this would be an example to use to record the motion of the box and then watch the video in slow motion, so you can spot exactly the time of accelerating, and then positive acceleration and negative acceleration, slowing down and coming down to rest. So here's an introduction of friction and normal force. Thanks for watching.